Hello everyone, welcome to the lesson of basis and dimensions and based question. We will discuss CSIR-NET December 2018 question, which is based on basis and dimensions, topic of linear algebra. Now, basis is linearly independent spanning set. Basis follows two conditions: linearity independence and spanning property. For standard basis of coordinate vector space Rn or Cn. For generalization, we will consider two space n equals to 2. If we consider from origin to x direction, one unit is here, therefore this point will be 1 0. Similarly, in y direction, this point will be 0 1. We can see ex or e1 is 1 0, similarly for e2. Now, in two space, standard basis will be e1 and e2 written or denoted by this notation. There are so many other notations for standard basis. We are considering generally e1 and e2 written in this curly bracket. Now, in Rn, standard basis generally e1, e2 up to en. For example, E1 and E2 formed a basis of R2 like this way. From here we will obtain all the scalars. These are known as scalars. A1 and A2 will be 0. If all the scalars will be 0, then Li linearly independent. Also, any pair of two vectors will be linearly independent if one is not multiple of the other. These are also vectors into space which are not multiple of each other. They forms a basis also. Generally, basis of a vector space is not unique, but number of elements in each basis will be same. For polynomial of degree n, the monomial basis will be this one. This basis will be written in the increasing or decreasing order. We can say ordered basis. For matrices of order m by n, for example, we will consider here a matrix of order 2 by 2. Standard basis for order matrix of order 2 by 2 is even 1. Generally, we are denoting this one by even. This is 1 0 0 1 and even 2 or e2 0 1 0 0 1. Similarly, e2 1 and e2 2. These are standard bases for matrix of order 2 by 2. Now, dimension. The cardinality of a vector basis of vector space V over its base field. That is the dimension. Dimension of vector space is uniquely defined. Now, dimension of matrix of order m into n will be m into n. Dimension of matrix of order m into n, if sum of each row will be 0, the dimension of this matrix m by n will be mn minus m. Similarly, this is symmetric matrices of order n by n, dimension will be nn plus 1 upon 2. Also for skew symmetric matrices ny of order n by n skew symmetric matrices, dimension will be nn minus 1 upon 2. These are few dimensions of some matrices we have considered here. Now, this is our basic question. So, W is 1 vector subspace is given by this one, W2 vector subspace W2 is given by this one. We want to obtain dimension of W1, dimension of W2, dimension of summation of both, dimension of intersection of W1 and W2. These are 4 options we want to discuss. There is a rule. If we want to obtain dimension of vector subspace, we will obtain the dimension of W1 or vector subspace. We will treat whole the subspace as vector space and follow the rule, or we will use this formula. Dimension of subspace will be dimension of vector space minus number of Li restrictions. Now, for W1, this is the coefficient matrix. This is the coefficient matrix of these restrictions. So, we will obtain here coefficient matrix, and rank of this coefficient matrix by row reduced echelon method will be 2. Therefore, dimension W1 is dimension R4. Dimension of R4 minus rank of this coefficient matrix by row reduced echelon method. Therefore, dimension of R4 minus dimension or rank of coefficient matrix E. So this is 4 minus 2 is 2. For W2, this is coefficient matrix. Rank will be 3. Dimension W2 is 1. Option 2 is not correct. Option 1 is not correct. For intersection, coefficient matrix will be this one. We obtain rank of this coefficient matrix C by row reduced echelon method. So rank is 3. Dimension, this intersection will be 1. Therefore, option 4 is not correct. Let us consider this dimension. W1 plus W2, using this formula, putting the value, we will obtain dimension will be W1 plus W2 is 2. Therefore, only option 3 is correct. Now, these are some practice questions checking comprehensions. Let V be the vector space of all 2x2 matrices over reals. W1 is given by this one, W2 is given by this one. We have to obtain dimension of intersection of W1 and W2 and dimension of summation of W1 plus W2. These are answers. Another question will be this one. Answer will be dimension W is 2. You can solve easily. If facing problem, you may discuss. Thanks for watching.